Okay guys, you wanted some help with the 4-link calculator. By default it opens it up with a single triangulated setup. This is mine, it is custom. So first thing you want to do is open it up with at least Word 2007, I'm sorry, Excel 2007 or newer. First thing we want to do is come up here to where it says enable editing. We're going to click that. What that does is it turns on the macros inside of the actual Excel file so that you can customize this stuff. So this is close to what we're doing. The numbers are a little off, so I'm going to go through this with you. These light blue fields are the ones that are editable, that you can put your numbers in, okay? This is going to help you out here. So we are shooting for about 124 wheelbase. Our tires currently are about a 44 inch. The rolling radius makes that about 21.5. You don't get quite 22 inches. Our center of gravity height is actually much higher than that. It's about 47 if I recall. Our mass is going to be nearly 6,000. And we're going to incline this just a little bit to overshoot it. We're going to go 800 on that. And your unsprung mass, that's kind of like your axle weight with all the gear on it. So that's a start. This gives us an idea. You might also have to enable the content. Microsoft's kind of touchy. I am actually a computer technician. I own a computer business in Almsville, Oregon. So we're going to enable the content there. What I clicked, and that'll allow a lot of this formulations to do its job. So first thing we're going to do, I'm going to do this from memory here. So if I remember right, what they're asking for here, this is your frame end of your upper link, and that is shown here in these blue bars. Okay, so the first one, if you hover your mouse over it, it says forward from rear axle center line. So what this means is if this line here was the center of your axle, which if you scroll down here, let me get over here and scroll down just a tad, too far. You can see that it kind of locates things for you virtually here. So that's showing that's 0 to the center of the axle. And then your overall length, you would think would be the total length of your bar, but it's actually where it ends up straight on from the axle center line. So what we'll do, so come up to the top here, where it says frame end, it says forward from rear axle center line. If I remember right, I'm like 54.5 is where we'll start. I actually have a picture of our actual numbers, so I can put those in. This is an old copy. So here it's going to ask for, I believe this is our separation, half of your upper link horizontal separation at the frame. So that's talking about these numbers here. So what you're going to do is measure this complete width, divide it by 2, and that'll give you your deal here. That's half of your upper, obviously. So I believe we're like 54.5 or something like that. We're going to just put some virtual numbers in here to try it out, just to give you guys an idea on how this functions. So let me think here. 54.5, that was 25.25, if I remember right, is where, whoa! There we go. Had an extra dot in there. Height from ground, we were at 33 inch at full bump. We're going to build this at full bump first, and then I'll add the inch in to the height from ground on the frame end on these values here. So next, again, it's center, so don't worry about this. This is our upper horizontal separation at the axle. Ours is 5 1/4, or no, I'm sorry, it's 5 1/2. So it's, I remember it's 2.6 is what this number value is. So this gives us close here. This gets us a separation of more than 50 degrees, if I recall. How we figured that out. You want at least 45 degree separation here at your top. You want to make sure that these bars, that's what centers your axles and keeps the side motion, so you don't have any side motion to have this axle go back and forth. So that's a start. Okay, so we got that pretty close there. Our red links are actually much longer and they're much straighter. So what we're going to do is go ahead and take care of that. Right here, they are 4 plus to be 59.5, if I remember right, because we actually have ours leading off the front of the axle slightly, and it's 4 inches. Let me see here. That one is 4 inches. So I'm just pretty much rebuilding this right from scratch, and you could do this from raw numbers again. So here's your half of your lower link separation horizontal at the axle end. So we have a total of 48. There should be about 24 if I recall. Okay, and then down here, this is way off. This should be at the frame. We have that at about 34, so half of that is what? We'll go 17.5 just to be close. That's too much. It's going to be more like about 15. That looks realistic about what we have set up now. So here we got some other numbers. This is height from ground on the frame end is obviously not 15 inches. Lower links are from the ground on the frame end were 27 inches. And on the axle end, they are, if I remember right, gosh, this one's a tough one, guys. They're talking about, yeah, see how low that is? That is not correct. This should be up higher. If I remember right, it's 19. Pretty sure it's 19. See, that looks about right where our setup is now. That's really close to our double triangulated 4-link there. Let me see if I have all of the numbers inputted here. Give me just a sec. Okay, now if you go down here to where it says travel, you'll get this tab down here. We're on the main tab, and now we go 2 over to travel. There's some stuff in here that you can do as well, and you would think 10 inches is what you'd want to see, but it's actually -6 will give you a 6-inch ride height. And now if we go back to main, this should give us some different numbers. For some reason these aren't coming up. I might have a different version of this. I need to grab the other one, but this gives you a rough idea, guys. Play with these light blue fields, and if you're unsure on something like this vehicle center gravity height, that is typically, if you are an iron block, it's typically the bolt, your highest bolt on your transmission bell housing. If you're an aluminum guy that has like a really light motor, an LS or something like that, they say the center of gravity height is about halfway up the transmission on the bell housing. So a couple holes down, you gain 2 or 3 inches because of how light it is. Mass, obviously, that's the total weight of the vehicle. Your wheelbase measured, hub to hub. We wanted to go a little bit smaller, but this rig is going to be doing multiple things: hill climbs, rock bouncing, mud bogs, go out to the sand and play, climb on the rocks. We've got multiple transmissions, all sorts of stuff for it. So I think we're close on these numbers. Everything looks pretty dang close. That's about what our deal looks like. And for some reason, this version doesn't have the travel. So let me get back to you. We'll post this up here, and make sure that when you're done, what I like to do is keep the original. So make sure you go to Save As, and throw this somewhere where you get a second copy, like, step 1, step 2, step 3, whatever works for you. That way you can go back and look at your changes, and then you can get real familiarized with the characteristics of your suspension. Again, the biggest thing that you really want to do is make sure your uppers, that's signified in this blue bar, it goes to the frame end. Make sure your frame end's got some adjustability, because this is what's going to give you a good anti-dive number or anti-squat, depending on what you're working on. This calculator, from what I've read and from the videos on rock rods on YouTube, they state that anti-dive is for the front and anti-squat is for the rear. So this value is actually the same for the front. And in the front, obviously, you want a lot of anti-dive, because you don't want that nose to dive down when you step on the pedal, obviously. So, the optimal range, I believe, is between 90 and 110. 100% is about right in the middle, from what I understand. So we've actually been able to adjust ours. So if I go lower here, you'll actually see that value increase. We've got 4-link adjustments on the upper frame side. So what I'm going to do is lower this. And instantly went from 70 to 91% anti-squat. So this is going to kind of help you guys understand a little better what you're doing here. Anti-squat is actually for the rear, but what you want is be able to adjust it from that number. You'll have about 3 inches of adjustment in your upper. So you want to go between 90 and 110 is what I am shooting for. That's what I would suggest for the front. The rear, if you're stepping on the gas and your ass is dropping, you need more anti-squat, so from what I understand. Again, I am a little new at this, but I've spent many hours looking and researching this form. There's so many things down here that you can get lost in. You know, the plot, the coordinate material. This will show you all your actual tensions and your strengths of your links. You can choose. These are all drop-down boxes. So man, boom, you know, put your steel in. Sizing, obviously we're not going to do 120. That's going to be 250. That should be adjustable, or you can just put in 250. Yes. You know, and the outside diameter is obviously going to be 2" in ours. So that kind of helps. But it'll give you a lot of the tensile strengths, from what I understand, and the elastic strengths, from what I understand. You know, I'm not real keen on that. I'm still new to that. I'm kind of a visual guy. I've been self-taught on everything, and if you're following some of our build, we're doing pretty good so far, I believe. So, again, that's it for now. Hopefully that helps you guys out, and you know, stay tuned. Thanks.